Okay, thanks for that, Andy. Right, good evening and welcome to all our members, friends and visitors once again. Thanks for supporting tonight's East Midlands branch event. A little bit of housekeeping first, if I may. Can I just please ask that you keep your microphones on mute? It's just so that we don't get any background noise, so we don't have distractions for our speaker. And please post your questions on the chat function and prefix them with a capital Q. But before I go into our speaker for tonight, we've just been given some good news. And please pass this to your friends and colleagues and other members of IOSH, that IOSH are trialling a face-to-face beginning in January. And it's looking good for us for a March update on the legal update with an IPD, CPD clinic, and could be supported from IOSH HQ as well on a round table. So want to keep your eyes and ears open for, please. It'll be great to get back to meet you all and have that chat. So please bear with that and keep your eyes open, as I say. More information will be posted out on the mailers, LinkedIn and Twitter as we get closer to the time, of course. But tonight, first of all, I would like to thank Galina Hobson, one of our committee members tonight, for taking the lead on this event. And she arranged with Russell Manton, who's our speaker, and the subject, as you know, is rope access. Russell is an IRATA assessor. He's a chartered member of IOSH and has extensive global experience. He's a great speaker, and I'm sure there's a lot more that I haven't said about Russell's experience. So please, Russell, you can expand on that, and it's over to you because we're looking forward to your presentation this evening. So thank you.
Cheers there, Alan. I'll just get the screen up. So what I'm going to do is share the screen. Hopefully everybody can see that. Okay, so hello. First of all, thank you to Alan for that, and thank you to Galina Hobson, because this is really a brainchild, getting it over the line. Thank you for inviting me as well just to explain rope access out there to the health and safety community. So the main reason for this presentation is to really shed light on rope access, to give it a better understanding, give the health and safety community a better understanding of it. Even though it's becoming more sort of mainstream now, I mean, we even see it on TV adverts occasionally, but it's relatively new. It only came about sort of the last, 20, 25 years it came to light. But there's still pockets of resistance I'm coming across, definitely. Even, not too distant past, I saw some stuff on the IOSH forums, and the conversations were treating it with trepidation. So it's mainly to, as to say, put the spotlight on it, dissect it, and we can try, hopefully dispel a few myths, as I would like to say. What I'm going to be doing is going through these slides. I'll explain the concept of rope access. I'm going to explain its applications, where it's used, how it's used, look at the industry sectors in it, where it's been used as well, the environments it can be used in, the advantages, and I'm not going to go on the hard sell here. It's basically looking at what we can gain from it, and some of the times, we can't use it as well, where all the systems will be used in place. And I'll talk about IRATA, which is the Industrial Rope Access Trade Association, and they're the trade body who governs the certification. And as Alan said there at the end of the session, hopefully there'll be questions there that myself and Galina can go through and answer as many questions as possible. Okay. So a bit about myself. I started rope access in the early 90s. Before that, I was actually an electronics engineer, and I also had a very, very keen interest in rock climbing. And it's when a friend of mine who actually worked for Canton, they're operators in rope access, suggested that I might amalgamate these skills, put them together, and try and start doing some work, earning money in rope access. Basically, I thought it'd be an interim job. I thought it'd be, just a bit of part-time cash or something like that. Well, I got through my electronics apprenticeship, but here I am 30 years later, still doing it. the thing is, it's kept me in there. It's nothing to do with being an adrenaline junkie or a thrill seeker or anything like that. It's purely to do with the challenges of the job, the challenge of controlling the situation, minimizing or eliminating all the risks, and doing it really efficiently as well. The other thing that I found that kept me in, and swept me along with it is basically all the people I was working with, all the technicians had a shared belief in doing the right thing. They all wanted to do the same. It was all about the pride in the work at the end of the rope as well. So we spent all that time getting into these difficult locations, and they wanted to do a really good job as well. It wasn't a kind of budget and scarp. It was do it to the highest level, and then hopefully, the clients would ask us back. 1997, I started running teams. That was onshore, offshore, internationally as well, working with a lot of foreign nationals. And in between the lulls of running jobs and contract work, I actually found myself doing a lot of instructing in industrial rope access as well, which I found really fulfilling, to be fair. I thought it'd be a case of just a little crossover till we got back out on the contracts, but I actually gained a lot from it. It was fulfilling, and it was a chance to put back into the industry, and I learned a lot myself as well. That eventually led me down the assessing route. So IRATA eventually appointed me as an IRATA assessor. So therefore I was traveling around the globe actually doing it. So these training courses that we put together, we actually train people, and then they've got to be independently assessed by somebody like myself. And what I found there was, I've been over to places like Alaska, New Zealand, many times to India, Eastern Europe. They were all working from the same IRATA blueprint. It migrated really, really well, and that impressed me. That was something that I could go to the other side of the world, and they're working to the letter of the IRATA documents. So that was really good. At the front of all this, the forefront, health and safety was all there. That was the main thing that always impressed me. So right from the outset, I remember going to one site, was in the transit van driving on the way there, the supervisor with me, and on one seat was taken up with all the site files. And I thought, that might be for an entire year's worth of work, but it was actually just for this one job. It was full certificates, inspection records, risk assessments, method statements, procedures. It was all there. And I questioned the supervisor, and he said, well, basically, it's more than likely, as soon as we get there, we'll be stopped by the health and safety representative. They want to go through all our documents again. Or even when we start the job, we're more than likely to be stopped. And then, just to double check what we're doing is right. Rope access always drew attention to itself. If you imagine you go on a construction site and you see all these normal activities or what you associate with construction sites, then all of a sudden you see a couple of guys hanging off a structure with a high-vis vest, you're more than likely, you're going to hang on and say, what's this? Looks like a circus act. So we were put under the spotlight in the early days, and still to this day we are. So we have to put together a really good health and safety case. What really impressed me as well, with a lot of my colleagues and peers, they could recite loads of sections of the regulations and codes of practice as well, which impressed me. And I think ultimately that's what led me down the road to become a health and safety practitioner, a chartered member of IOSH. It's many years of doing it, and I'll have to say I'll give Rope Access the credit of that and the system we worked with. So what is industrial rope access? Well, it's really an amalgamation of climbing techniques and caving techniques. That's what it's all about, really. And I've got to give the nod to the caving community here, because there's quite an important thing here. I was told in the early days, with climbers, they tend to use their physical prowess to go up a rock face or a mountain, and the equipment is a form of mitigation. So it's there in case they fall. So they're not really using the equipment, it's only in case they fall. Cavers to progress around a caving system are reliant on the equipment. Caving systems generally are full of water, running water, silt, mud, physically very difficult to climb. So they're reliant on their equipment to move around, progress around. So with that in mind, they became very proficient at going up and down the ropes. And really what Rope Access has done was took that to one side, and they've honed in this technique, what's called single rope techniques, going up and down the rope, and they've added another rope with it, or a line as we call them, where we can put this attachment on in the highly unlikely event if there's any failure. basically we've got this redundancy system. So that actually ties in with the working at high regs. It actually comes under the banner of this work positioning techniques. Now, I'm not going to go through quoting all the regulations, go through the whole lot, but basically with work positioning, traditionally, in a sense, that's always been about this full arrest system, and we're adding a work positioning belt so we can go hands-free to carry out a job. Telecoms have used it, steel erectors have used it for many, many years. And rope access really is a form of that. We've got a primary attachment from this working line or working rope, and then we've got a complete independent backup system. So it ties into the working at height regulation and all the legislation. So just to look at this in more detail, we break down, disseminate, dissect what we're actually doing here. You can see this technician here has got this rope. They've got the main working rope, or we call it a working line. And then there's a mirror image. It's almost like it runs parallel with a working line. We have a working, it's a backup rope basically with a device that will run up and down. And as I go back to what I said before, in the highly unlikely event, any failure of the main working line, the backup system will kick in and arrest a fall. Now, before we go any further, people think, well, the rope access guys just go into the job thinking, oh, well, it doesn't matter if something happens, we've got the backup. The last thing you'd want is your primary rope to fail whilst you're hundreds of feet up on a structure and going into an uncontrolled descent. Sure enough, the fall will be arrested, but that's the last thing we want. So the actual working lines, we go to the nth degree to protect those so there's no failure whatsoever. So we'll say it's the highly unlikely event. We're putting these massive safety margins in. And if anything, I found myself in a few situations where we're working on 2, maybe 3, or even 4 ropes to get into a position and put all the redundancy in place. So just go to show how much we put in place. So we've got working lanyards there, device lanyards, where we can actually attach onto the different lines. So if we need to move from one set of line to another to get across safely while we're maintaining all these points of attachments. The harness we're using, it's what's called a sit harness. It's actually modelled around a mountaineering harness. We've got this waistband with these leg loops actually support us from the waist. We have this ventral attachment. So everything's round about the waist point, but then we have these extensions going up to the chest, which allows us to put the certified fall arrest equipment on. Tool tethers, obviously, and all the rest of the associated PPE. Now, the actual device, the descending device we use, traditionally, when it comes to abseiling, we've always used these. Physically, you can't hold onto a rope and climb down a rope or up a rope. You might be able to, but you won't get too far. So the idea of an abseil device, what it is, it introduces friction into the rope, and you control the rate of descent with the other hand. Traditional mountaineers have used figure-of-8 devices, stitch plates, these kind of things. So it puts all the heat and the friction actually into the device. It dissipates the heat, but it takes the hard work away from your hands. The device we use is self-locking, because if you let go of the rope through a traditional device, basically it'll go into an uncontrolled descent. So the devices we've got are self-locking. These have been developed over the last 20 or 30 years now, actually. They've been really refined and they meet this industrial standard. So it's like a dead man device. If you let go of it, it just locks out onto the rope. And we can get added security by further locks to put on it. So there's massive control there. So if the user was not incapacitated or accidentally knocked anything, you're not going to go into an uncontrolled descent. It holds you in position, okay? So we might be working over water, we could be on bridges, oil rigs and things like that. We've got to be able to ascend up the ropes. It's not simply about just coming down the rope and doing a job. It could be climbing back up. Obviously, if you're working over water, you're not going to go down into the water, So what we'd have to do there, we'd have to climb back up the rope. And so what we're doing is putting these 2 rope grab style devices onto the working rope, and we exchange the actual descending device over with these a combination of actually 2 rope grabs. One's attached to the harness, one's attached to a lanyard, and in turn attached to a foot loop. So we're actually, by using these combination devices, we can progress back up the rope. And you can see just next to the working rope and the working line, we've still got the backup line. That remains there pretty much doing nothing, hopefully remaining inert, nothing will happen. But as I say, that's always with us in mirror images, what we're doing, going up and down. So the technique in itself is called SRT, single rope technique, and the actual backup device has been included on the top of that to give us this 100% redundancy. So we've got this complete coverage backup system. Other harness-based work we can do, we're not simply just climbing up and down the ropes or moving up and down the ropes. We can traverse off the ropes. So we're using a technique here called aid climbing. So what that's actually doing, it increases our repertoire where we can get to. So if a client came to us and said, look, we get down to this point, be off going sideways into a structure, then that's where we'd use this. And again, this would probably come from the climbing world more than the caving world, where if something's physically too hard to climb, we're reliant on the equipment to hang in. It puts us into work positioning. It's actually a very, very effective system. We're still using the 2 points of attachments, and in some cases up to 2 or certainly 3 or 4 points of attachments when we're getting past obstacles. And the beauty about this system, you're actually in work positioning all the way along. So you're physically not actually climbing the structure. In the highly unlikely event, I keep using those words, but in the highly unlikely event of any equipment failure, the free fall you'll receive, or an end user will receive, is going to be no more than 500 millimeters. It's actually tucked right down. So that'll beat any fall arrest system. And with this, predominantly we are traversing, I would say, horizontal progression in a lot of structures. You can see it has been used on a stadium, but in some cases you can actually go diagonally, and basically vertically, any direction you want, as long as it's safe and you've got all the attachments there. Now, this will use rope to actually get onto the structure, to move around, and at the end of the day, we'll use the ropes to get back off it. But to say, it does really open up what we can do as an industry. Also included in that, it's not just limited to abseiling, ascending, and you know, the aid climbing, what I mentioned. We're using the more traditional methods where it's fall arrest, work positioning, and work restraint as well. So within the IRATA system, we're always working with this hierarchical approach, okay? So with that in mind, the work restraint, or travel restraint as some people call it, is basically that will actually stop us going over an unprotected edge, and that's a really heavily used system. So when we're actually training this, and when we're actually using it on site, that's something we'd always go to. It's the go-to method. It's obviously, we're there in a place where we're using the PPE to do the job. It's already been accepted that we can't use other methods. We're using the PPE, and this is the first port of call to use when we're using a harness-based system. Work restraint will actually prevent fall from occurring in the first place. Sometimes full arrest systems are used for the primary access, and it's basically just get into position. And once that technician has got into position, then basically we'll set up a more improved system or something a bit more permanent, semi-permanent, and effective to get technicians up and down into the structure. Rescue is also built into it as well. So basically with this, we can't be reliant on emergency services, and it's actually integrating what we're doing. We've got the 2 broad categories of rescue. In the picture here, we can see this intervention style rescue, or we simply call it a snatch rescue. And there's also, I'm going to talk about in a minute, a rigged for rescue or a pre-rigged system. Okay, so I like to use the words application specific. You've probably heard this in health and safety terms. The rescue you choose or pick for the job is dependent on the location, the type of work you're doing, and the environment you're working in. And we've got to choose that carefully, and that's down to risk assessment. All technicians are trained in the basic intervention style rescue, and to be quite honest, that actually covers more ground than any. Most situations will find themselves in descent on a rope, and all technicians are capable of doing that. If it starts to get more technical, then obviously the team competence will have to be upped for that. But simply, we can't go into the job into a difficult location and not expect to get somebody out or evacuate them out. So that's why we train for these all the time. The next one is this pre-rig system, or rig for rescue as we call it. So the difference between this and the intervention style rescue, intervention, the rescue will actually come down to the casualty, pick them off the ropes and take them down. With a pre-rig system, you're actually remotely affecting the rescue. So you can do it from a point of safety. Now, a lot, and I've seen this happen a lot of times as well, things have come up on LinkedIn, and health and safety professionals said, well, why don't you do this all the time? You should be doing these pre-rig systems. It's obviously, you're not putting the rescue at risk. It's the way to go. It's not quite as simple as that. As I say, it's not a risk assessment, the environment you're working in. Pre-rig systems are perfect. You protect the rescuer, but there's the limitations are, and you do have limitations in these rescues. You might get the casualty snagged. And going back to the intervention style rescue I showed you before, the casualties are actually with the rescuer there, so you can maintain their airways, you can do all the casualty management, and you can actually take that casualty past any obstacles on the structure. So they do have the pros and cons, and as I say, it's competent people within the teams will decide what rescues we are going to use for the particular job we're doing. So where's actually rope access used? Well, it's used in a number of applications now because it's safe, non-invasive, quick and easy to set up, dismantle. It doesn't displace other more traditional methods by any means. I'm not saying you don't use scaffold, use rope access. But to be quite honest, I've worked on a lot of contracts where we're working alongside the scaffolds, where we're helping them, assisting them set up a temporary work program. It's basically, it can cut down a lot of work time if you're looking at go back to our reasonably practical when we're deciding what work methods to use. And it can cut down on cost, duration, and inconvenience in a lot of cases. So that's where it's come into place. We're just going to look at a few examples of that. One large example, I say we can actually compartmentalise our industry and where it's split up and how it's gone and how people are specialising. One big part of it is actually inspection. This particular slide here is that a technician's come down a structure and they're carrying out what's called NDT inspection, non-destructive testing. So this is something I've been involved in over the years. Non-destructive testing is utilised in loads of different industry sectors. We can use it for offshore, onshore, bridges, aircraft hangars, boats, you name it. And what they're doing is actually coming down, as the name suggests, we're not actually taking samples, but we need to be there right at the structure to do this testing. So they're using ultrasonic methods, radiography, and we can actually tell the thickness of certain structures. It might be part of an inspection program and an inspection regime that they've got to maintain these structures, and that's a big part of rope access. So you can see this technician's come down, they've locked off the descending device, they've got into a work positioning location, and they can carry out, they've got the hands free to carry out the work safely. And they can get into a number of locations like that really, really quickly and safely as well. Bosun's chairs is something that has cropped up over the years, and people say, why don't we use bosun's chairs? Because that's a very traditional method. It takes a lot longer to set up, and it's quite limiting in what you can do. I'm not saying it's bad or anything, but rope access will have the added advantage of getting around because it's a lot more nimble, and a lot more people view it as safer. On a side note, I actually work alongside a lot of steeplejacks, and steeplejack teams have always used bosun's chairs, and they've actually moved over. The majority of the leading companies in the UK and overseas have adopted the IRATA system and now starting to use rope access alongside their traditional methods. Confined space works is something I do a lot now these days, and rope access comes hand in hand with confined space. The capabilities of it, what we can do, you can see this technician here has actually been lowered down with full BA into a high risk confined space. We can actually get that technician a lot further into the confined space and extract them a lot quicker as well. So we gain a greater range of what we can work in. Added advantages of this, the whole team's fully versed in the equipment. They're using this stuff day in, day out. So when it comes to an emergency, they've got complete understanding of the situation, and they'll all be able to swap around and use the equipment. Another example of the confined space is application with the rope access is this ventilation shaft. So this has been basically, you know, a lot of people go, well, why don't you use CCTV for this? Or you can actually get these UAVs or drones to actually go into confined spaces, but there's still limitations. You've got these two abseilers here coming in. They can go down under their own steam. Basically, they've got control of the descent on this, unlike the picture before. And if you're going greater distances, it's probably a more efficient way of doing it, because these guys are qualified in what they're inspecting. They know what they're doing. They're engineers, but they can control the rate of descent at which they go down. So they'll actually cover more ground efficiently doing it in this method. Other advantages, they're next to each other, they can rescue each other, and also they'll have a topside team here as an additional backup to get them in or out of that confined space. It's not always about rescuing down, it's in a lot of cases, certainly confined space, it's going to be rescuing up as well. So it is a very effective way of doing this. Also, if there's any loose debris as well, an advantage, you've got somebody there actually in the location, you can actually remove that debris and actually perform a safety check while you're there, which is actually a bonus. Don't forget these ventilation shafts run right down onto rail tracks. And if you've got any loose debris coming down on a moving train, that's a major issue. So that's one of the reasons we do these inspections. Periodical inspections of the shafts, just make sure that they're clear, no loose debris. As I say, we can remove stuff while we're actually there doing the inspection. Installation work. So in this picture here, this technician is actually installing something for a more permanent system to go in place. So they can come in, put all the installation points in, and then the engineers can come in and just simply install the ladder system that's going to go into place. You can see in this picture, again, hands-free. They've got total control of the situation there to actually carry out the work. And if you look at the slide carefully, you can see the guy's got this small seat. Now, it's not exactly an armchair or anything, but it will provide comfort enough so they can stay there for a longer duration. Work position is generally designed for short duration use. They say maybe 20, 30 minutes, but with the work seat, we can actually increase that time. It's obviously dependent on what the technician's comfortable with. The work seats, or comfort seats as we call them, are mainly to take the weight of the technician out of the harness a bit more. All the same safety systems are staying there. They're all rigged in with the 2 points of independent attachments. So the comfort seat's really taking the weight out of the harness a bit, so we don't have any long physiological problems occurring with the technician. Other things, you can actually hang all the equipment off the seat as well. You set up a miniature sort of workstation, and it's actually quite a useful way of carrying out engineering jobs, installation works as well. Going back to the aid climbing here, was a team of climbers that have come out onto the structure here. What they're actually doing is putting safety nets in for a contract out in an Arab Emirate country. I think it's probably Qatar, actually doing a lot of stadium work out there at the moment. So they'll climb up, they'll probably use the ropes to actually gain access to the initial structure and from there traverse out. You can see they're taking ropes with them as an umbilical system so they can pass equipment in and out to the technicians from the ground below. And also if in the event of any rescue, we can actually get the technicians off. They're all working in close proximity. And what they're doing is setting up this more permanent safety system for other workers to actually come and do the roof. So going back to what I said before, we're actually working alongside a lot of more traditional access methods, helping and aiding to install these. This is a more extreme location. Again, I've carried out quite a lot of this work in the past. These technicians have actually gained access from the actual pier of the suspension bridge. And then they come along the specialised walkway at the top. And the likelihood is that they'll be coming down, I wouldn't say the entire length, but we use this method a lot to actually inspect the cables, mainly the nodes at the top, the connections where the cables have come up to the, meets the main walkway there. In this method, you can get a team of rope techs down there. They can basically climb down the walkway, set up a system, and then they're probably required to abseil maybe 10, 15 meters below there to do all the inspections. They'll come back up onto the walkway and strip the system out. So you can see the nature of some of the work we actually do and the locations we can get into. A site like this or a job like this, the team size are predominantly, I'll go into the levels of competency, but they're more than likely to go full team at level 3. They're very competent people who are already very seasoned at working at height. You can't reasonably expect to throw somebody in who's just done a course on rope access and throw them into the deep end with this. And any leading member company would never do this. They're very carefully mentored and held through, and made sure you don't end up in an exposed job like this, because it really is the exposure on a job like this will take the technician off guard. Telecoms, again, we're branching out here. Telecoms traditionally, when it was putting up the actual antennas and then running the cables down, it was always done by fall arrest systems. So you're physically climbing up and down using fall arrest lanyards to get into position, then adding the additional belt on there so you've got your hands free to do the installation work. Now, with rope access, where this is really coming to its own with telecoms, is you can do the installation, and then the cables can be run down a tower, it could be run down a building in a cable tray. It just depends on where these antennas get mounted. But that technician then can abseil all the way down, putting the cables and the cleats all the way down, and they can do a really neat and tidy job. And it's not as exhausting as well. It's a better, more efficient way of doing it, because they're just held there in suspension in a work seat where they can carry out this work. Geotechnic environment, that's the natural environment, and this is a vast amount of work carried out doing this. Going back to the inspection slide I showed you before, rope access teams, I would say a lot of companies are heavily involved in this. It's generally ongoing work. It's in the natural environment, so we're talking about railway cuttings, motorway embankments, and the main reason for this is to shore them up, to make sure we've got no loose debris coming down to railway tracks or roads. It's been used in quarries. I've seen a lot of business premises being put into quarries, and we've been involved in shoring those up so we don't have any loose debris coming down into the business unit. And what it entails really is the rope access techs will come in from above, abseil down. The type of work they'll be doing will be descaling, so taking any loose debris off, devegetating the slopes, meshing up the slopes, and can even drilling into the slopes. We tend to use a lot of big equipment on this, pneumatic equipment to drill into the slopes, grouting and underpinning the slopes, so there'll be no landslides that could occur. And I'd say is a big mainstay in the rope access industry worldwide. Can, Galena actually works for, who's put this presentation together with myself, their company Can is actually one of the leaders, I would say, one of the oldest and biggest companies that have been doing this around the UK and actually overseas as well. The maritime industry, so obviously we work in offshore oil and gas, but the maritime industry has been a big client, and it's something I've got involved with heavily for a number of years. But the main reason we're out there, we get helicoptered out to a ship, and then we're asked to do NDT checking of the cargo tanks or external structure of the ship. Big advantages of this, these ships are moving around, they're trading, hundreds of thousands of dollars a day, some of the clients. And if a ship has just dropped the cargo off and it's going back to pick up more, then a rope access team can join it and carry out any interim inspections that are required to do. It's a bit like MOT in the tanker in a way, for want of a better word, really. So we'd go in there and do a full NDT check of all the structure and provide a report to the insurers, Lloyds and people like that who underwrite it. And it's basically to make sure they're still seaworthy. So rope access has been a huge bonus for the ship owners. The companies doing this, as I say, you can sail with the ship. Even with cargo, they can switch the cargo from the different tanks, and we'd climb around the ballast tanks inside, or even the cargo tanks where the crude oil's kept, carry out all the inspection work, and by the time the tanker or the vessel's got to the other end where it needs to be, wherever the port is, the abseilers can leave or they can be helicoptered off. Previously, before they were doing that, the ships would have to go to dry dock, which was lots of days missed trading, cost a lot of money. And the big thing, you're getting huge teams of scaffolders in there to scaffold out the entire, all the cargo tanks and the ballast tanks. That's putting a massive amount of risk to all the scaffolding in the first place. So this is something we've really managed to turn on its head and get in there and reduce risk overall for many, many people. can do external work on the tanks as well, on the vessels. So there's quite a lot of work can be carried out. As the vessels can carry on moving, and we're quite happily working in there. You know, there's no dangers to ourselves doing that. Wind turbines, rope access obviously lends itself to that. It's become a big market in recent years. Obviously, you can see there's the government's really pushing for renewable energy, and that's not just in this country, but all over the globe, really. Rope access teams have been adopted in all countries now to inspect the blades, carry out work there. It lends itself perfectly for this kind of work because you can actually climb up, access the top of the turbine via a lift, then abseil down the blade. So obviously the blades are set to a Y position, and the abseilers will come down as a team, actually on the blade, and then carry out the work. You can actually get drone teams doing this, or UAVs, unmanned aerial vehicles, aircraft. But basically, they do have a limitation. They can carry out the work, but really, you always need somebody at the end of the rope to actually take samples or do the repair work. So we kind of work alongside each other. We find a lot of rope access companies are adopting drones and drone teams to go in there to actually inspect the blade, do preliminary inspections. But then it's usually you will need somebody at the end of the rope anyway to carry out the work, where a drone simply can't do that. Again, we've got another picture here. You can see specialist coating work going on to the wind turbines, actually on the tower itself. Now, this will be done externally as well. I've done a lot of internal and external work with this. Mainly, I was involved in fitting out systems or doing installation repair work inside the turbines in the early days when they first went up. So we could actually climb up and then abseil down the inside of the tower, the actual wall of the tower. These technicians here have come down the outside. They're doing specialist coating work. Generally with turbines, they've got a 25-year lifespan, and they really start to earn the money after they've been up a few years. So the clients are really keen to maintain them. So, you know, as I say, rope access has been a big player with this. They're very difficult to actually access. Otherwise, there are cradle systems out there, but they'll take too long to set up. And they're not that effective at the end of the day. Plus, there are one or two huge cherry picker style devices, you know, these mobile elevated platforms that are mounted on boats that can go out to the offshore platforms. But again, there's only a handful of them globally, and they cost a lot of money to do it. So rope access is the next best bet, really. So you used a lot of civil engineering here as well. So I'll go back to my point with the drones. I'm not knocking drone work in any way, but if anything, as I said, we work alongside each other a lot, drone teams to actually look where we need to be, and then we're sending techs down on the end of the rope to actually carry out the work. Because generally, more often than not, you actually need somebody at the end of the ropes to carry out the work. So the bonus factor here, this technician is actually carrying out what's called hammer testing. So you can go and looking for hollow sections in the structure. They can remove debris there, so there's obviously no danger to the public below. They can take samples as well. So we find a lot of the civil side, we're actually taking samples out of the concrete to check for concrete cancer and stuff like that. It's something stipulated by the engineers, and that's one of the requirements. So it has to be done by rope access. Otherwise, it means scaffolding right outside these huge high-rise buildings, which would be a nightmare. It takes too long. And again, we're looking at the risk factor overall for scaffold teams doing it. Cleaning. There's quite a lot of companies get involved in this. Generally, finding now modern buildings are equipped with BMUs or building maintenance units, the bespoke. So we've got the gherkin in buildings like that will have bespoke systems. They're really, really expensive to maintain. They can also break down. And you can get a team of abseilers in to cover. You can see that this team here in particular have actually covered quite a large area, so they could come down. So if the main, you know, the cradle system's out of use or damaged, you can get a team of abseilers in there to do the cleaning work. Rope access does have its limitations here, though. I'll give it that. So you can't simply throw a rope off a really tall building and think, right, it's okay, the abseilers can come down and they can get the lift back up. It's not quite as simple as that. Buildings start to get a certain height, or the abseils start to get to a certain length, the ropes themselves will have a limitation. And when I say it's not a safety thing, it's more to do with we just lose efficiency. The ropes elongate very slightly, a very small percentage. So if you've gone for over 150-meter drop on a building, 200-meter drops, which I've done myself, you'll start to find the rope elongating. Plus, if you're pushing against the side of the structure to clean it or carry out whatever work you're doing, you find yourself very quickly drifting away from the building. So you end up really fighting against that and having to use other techniques to keep attached to the buildings to stop you drifting away. As I say, it's not a safety issue. We're in 2 points in suspension, but it's to actually keep us at interface with the building to carry out the work. So that can slow us down somewhat. So as I say, that's one of the things with rope access. We can't do everything. We can cover a lot of ground, but that's one of our limitations, is really long drops. Got a team of abseilers here on Big Ben. So this really, it comes into its own here. I mentioned before about the setup time. It's not, it's very quick and easy to set up. It's not invasive whatsoever. And the equipment we're using is really lightweight. There's a lot of alloy components, and these abseilers are not the biggest guys, so they can just basically come down very gingerly, come across the clock face then to carry out intricate work on structures like this. So again, that's been a bit of a bonus. There's just a few examples there of how we've used it. Obviously, it's used in the entertainment industry and things like that as well. There's lots of different applications. It's just to give you a bit of an idea. So IRATA, I'm going to talk about this is the body behind it all, what their involvement is, what they're about. So it's the Industrial Rope Access Trade Association. It's a trade association that was set up by initially by the initiative of the companies that were doing rope access back in the early days, in the late 80s. They had to set this trade association up to kind of govern what we were doing, set up a syllabus to work to, set up a set of guidance and industry guidance notes that could work to. So the structure in itself it's mainly made up of committees. It's a non-profit certification body. We've got a committee chairman, various committees there for training, health and safety committee, equipment standards committee. We've got executive committee as well, over there, the overarching committee which make the decisions. General manager and secretary. The head office is actually down, it's in the UK. It's based in Kent, where all the administration is carried out work, worldwide operations, and for all the member companies worldwide. And then we've got these, what's called the regional area committees, which they're like subcommittees based around the globe, as I say, to get all this information disseminated around the globe with all these different time zones. It is a big challenge. So with these subcommittees, they can all feed back to the main IRATA head office. It's a certification and regulation body. So basically, they certify everybody involved. It's the rope access technicians, the training providers. So the people providing training have got to be regulated. Commercial operators, the actual operators of rope access member companies are audited. So in turn, the auditors need to be certificated, the assessors like myself, and also instructors will meet a standard within IRATA. We've all trained for these prospective roles, and we've all got to carry out CPD, just like we do in IOSH. We're continually monitoring what we're doing. Every year we've got the mandatory workshops we've got to attend, and personal training. So that is to stop skill failure, to keep that information current and relevant as well. Objectives of IRATA, well, obviously promote and maintain high standards, the work quality around the globe for the industrial rope access, promote continuous improvement and education, again through their website, through they do a lot of videos and publications that will put it out there on the website and disseminate that again around all the member companies. Increase awareness and the advantages of rope access. Promote the advantages of using IRATA certified companies. And currently they're actually working towards the ISO standard 17024, which is to do with the certification. So they want to get this ISO accreditation for this as a certifying body. That's been worked towards, and we're almost there with that, getting that over the line. So they're continually supporting the industry globally, working with government bodies, providing advice to industry. Got very close links to the HSE within IRATA. We've got a couple of HSE guys that actually work with us. So we've got a very good relationship working there. The British Standards Committee as well. The chairman's actually currently, he's one of the core members of PH5, the Equipment Standards Committee for personal fall protection equipment. So we've got close links there. And again, the information is coming backwards and forwards with these committees. I know they get involved with a lot of events for health and safety, HSE-based events, predominantly for the work at height side of it, but obviously they get involved with all these events. We're always working to this hierarchical approach, as we do with all the regulations, all health and safety. We're always working towards avoid. Now, if you're going out on a rope access site, you're there because you can't avoid it. You know, you're doing the inevitable. You're on to put a harness on. But even in that, like I mentioned before, if we are going to don a harness and do the work, it's going to be done in the best way possible. So it's going to be done in work restraint. So we're always going to go to the best option, the safest option. Okay. Tied into our code of practice, which we'll talk about in a bit more detail in a sec, is actually states in there, and this ties in with the BS 8437 selection of work equipment code of practice. But we've got to look at all other means of access. We've got to justify why safer alternatives have been ruled out before we use rope access. We can't simply just shoehorn it into the equation there. We have to do a very careful risk assessment and look at all options. Usually when we've brought in, as I say, it's for the snagging work or for when it's just simply impossible to use other methods. So we're up there with a harness, sticking to our hierarchy. So the evolution of rope access, where we've got around the globe, it's come a long way. Back in 1988, there were 6 companies in the UK. That was it, working out North Sea for the oil companies out there. Now, presently, we're looking at 606 certified companies globally. You can see a lot of them around Europe. You can see the spread all the way around the globe there, operating and training for that matter. So as I mentioned before, when I was assessing, I've seen this firsthand, the way it's actually migrated across the globe, the effectiveness of it, how IRATA has stayed on top of it. It's been one of its success stories. We've got this, you know, from Europe all the way to the other side of the world, and it's working wonderfully, and everybody's working to the letter. It's not been modified in any way. It's not been adapted or changed. It's actually working as it should be at the other side of the world, which has been a really good thing for me to see, actually. The code of practice we've got, that actually superseded a document which was industry guidance back in 2010. There was a colleague of mine called Paul Seddon. He's actually he was awarded an OBE for his work he did with the standards committees. He's been with us for a long time. He's just recently retired. This international code of practice was brought into place to supersede this industry guidance, and it's a very, very detailed document, really comprehensive, illustrations in, informative annexes, all the relevant legislation that we've got to adhere to. It's actually downloadable from the IRATA website. It's a huge document now. So if we're approaching it, before it was like a small sort of pamphlet or almost magazine size. So it's come a long way now. That the document is actually huge, and we're still adding to it, and we're still doing work. It's something I've been involved in recent years, actually, as part of a working group, a number of industry professionals getting together, working alongside Paul, as he's obviously the author, and we're feeding back into him our industry experience, what we feel is relevant, it should be included in that document for all operators of rope access around the globe. It's been brilliant to work on. It's been a real eye-opener as well. The information in there is absolutely amazing, superb document. And it's for all to see as well. It's not for just privy for the member companies. For anybody can download it from the website to go through. It's even received commendations from the HSE onshore and offshore in its use. again, I'm not going into massive detail here, but just to highlight some of the things we do cover in the ICOP. So there are some of the requirements. It goes right up to management level. The manager have got to be who are determining the job planning, who are getting involved in that. Ideally, they should be level 3, so they should be familiar with what's involved in that planning. They need to allow for the upwards communication from site. And when it comes down to supervisor level, you can actually see that again, a very comprehensive set of requirements. They need to fully understand what they're doing. I'd say be mentored correctly to get taking time to actually nurture to be in that role, because you go from almost being integrated in the team, and all of a sudden you'll be in charge of a team. Now it's actually mandatory to have a level 3 on site. So if we're working with a team, for example, these vary. It depends on the site, but it's a minimum team size of 2. Obvious reasons for the rescue side of it. One of which has to be a level 3. Offshore oil and gas, traditionally they always used a 3-man team or 3-person team. You'll probably have a level 1, a level 2 technician, and then you'll have a level 3 supervising that. Onshore, it could be any team size. So we allocate these supervisors to it be appropriate for the site. So if you can say a football stadium, any construction work on that, you could have 60, 70 technicians working on that. So you'll have multiple supervisors in sub-teams that will be overlooking what they're doing, and they're completely responsible for that team, looking out for them. And they've got to be empowered to make decisions to obviously stop the job. If it falls outside the method statement, or if there's something not correct there, it's outside the scope of the works. Could be damaged equipment, for example, or something's not quite right. Now, all the team will make that call. They do the pre-use checks and can actually flag it up and give it to the supervisor. But here, ultimately, it's got the power to go, yeah, we're stopping work. We need to withdraw equipment from service. So these are the kind of, the responsibilities they've got. On top of that, the ICOP, the other main document we've got within IRATA is this training certification scheme. So before that, we had what's called a general requirements. Again, a very small document which outlined the syllabus, what we had to work to for the technicians. But the training certification scheme is there for, it's again a lot more comprehensive. It's moved on from that. It includes a lot more. So there's obviously all the syllabus for IRATA 1s, IRATA level 2s and level 3s, but also for the trainers, the training companies we mentioned before, they've got to meet a certain criteria. The assessments and assessors as well. There's the whole criteria is detailed in there, and we've got to stick to that to the letter as well. That came in 2014. And again, that's something I've been involved in, making sure that's it's been translated out there into the big wide market. So this is just a very simple algorithm or flow chart. It does go into more detail, but I try to simplify it as much as possible. You can't just simply tip up and decide to become a rope access technician. You need training. And you can see we've got a 3-tier level. This is just basically for the technician grades in themselves. You get an IRATA level 1, like your entry level qualification. Some people call it 0 to hero. It is, if you've never done any sort of climbing or caving, it can be a bit of a shock to the system. The idea of this, you do a minimum of 4 days training, which is mandatory. You can take it over that, but 4 days is a minimum. And then you're independently assessed by somebody like myself to make sure that you meet the competency requirements of the syllabus. It's quite a robust system, I've got to say. It's very rigorous. It's a very physical course. It's very technical as well. So there's a lot going on. It's very practical based as well. So we'll find a lot of people coming onto it, even though it is a shock to the system. They really enjoy it, because even though we do cover a lot of theory on it, I would say certainly level 1 is very practical based. They've got more, on hands, just learning the equipment and the techniques and getting used to it. So that'll qualify somebody at level 1. That certification will be valid for 3 years. So obviously, we've got to revalidate it. It's got an expiry date on it. So we've got to revalidate it in order so we don't have that skill fade. Now, it is a strong recommendation that technicians, if they're not working on site every 6 months, they have to do some sort of form of rope access in a controlled environment to stay on top of their skills and techniques. So you can't technically just stay at level 1 and keep revalidating and that. If you want to progress up to another level, and make more of a career of it, then you'd go on to the level 2. So what you've got to do in order to qualify for that, we have these logbooks where we actually log our rope access experience. So there's hours actually spent integrated in rope access works on a site. It's a minimum of 12 months experience and 1,000 hours. Now that's a bare minimum. It's a strong recommendation of double that to anybody who's thinking of going up through the levels with the qualifications. We always recommend doubling that if you can, or even more. Just go up when the technician feels ready, and don't feel pushed by the company or just because they think they're entitled to. Because it is quite a shock to the system, again, if you're going for your level 2 and you've not got the relevant experience or required experience. Once you've got level 2, you're qualified, and that's the same procedure as level 1. Your the 4 days training and then independent assessment. Then you'll be classed as what's called a lead technician on level 2. They're designed, or the purpose of a lead technician is they can do the rigging. They can be working self-sufficient. They've got receive more training in advanced rescues, but ultimately they will actually fall under the jurisdiction of the level 3. They're still control of the site. The book starts with a level 3. So you can say it's the same time period from level 2 to level 3. You can do the 1,000 hours and 12 months experience, as I say, double preferably. And then you're eligible to go for your level 3, which is supervisor level. And at each level, you will have an expiry date, and we've got to stay within that. We get a reminder from IRATA telling you when you revalidate. It is a nightmare if you do let the ticket run out, especially for operational companies, because we don't want qualifications out there that have got no certification. The level 3 incidentally has to be first aid trained as well, so it's a relevant qualification for their environment. It meets the HSC recommendations in the UK, obviously. Overseas, it's whatever is relevant for the environment they go in. They've got to have a valid first aid qualification. So selecting a rope access contractor, if you're in management or a health and safety, in a health and safety role, so some of the questions you'd be asking, is the company from a recognised regulatory association or professional body? What qualification skill sets do they have? What arrangements will they have for managing the work? Will they be supervised by a level 3? Do they make checks on equipment and materials? And have they got some sort of quality assurance in place for the equipment they use? And that's really, really important. So using IRATA member companies, you would get that in effect because the company has been audited, externally audited by IRATA to make sure they meet the criteria. It is a fairly robust membership criteria. They're working to the highest standards. They're making sure they're complying with the code of practice. They're making sure that all rope access activities are supervised by a level 3 technician. So they've got to be present all the time. You simply can't have, say, 20 or 30 techs out there in the site and the level 3 is on site, but he's down in a cabin somewhere. That's not good enough. He has to be there at the coalface with the other technicians. So that's the idea. He needs to be overseeing what's going on in the event of a rescue. They need to be there straight away. And then they'll employ a full-time technical authority or a rope access manager. Somebody's allocated that role within the company, so you've got a point of contact there you can liaise with straight away. Checks you can do in the companies. So whatever qualification, if you're qualifying as a technician or a member company for training or operational, you'll be allocated, it's like a serial number, for want of better words. And you can do these checks through the IRATA website. So you can do background check. If you see a company coming in, they will be obviously brandishing the logo. And you can do a background check by using their serial numbers. You can actually dig in a bit further at what they do without going into their website. It's like a third-party verification to make sure that they are who they say they are and they can do what they do. So this company in question is based out in Turkey, but you can see the technical authority there, who to liaise with, and the type of work they're actually involved in as well. So this company actually does training on operational work, non-destructive testing, wind turbines, the kind of industry sectors that they go in. Some companies actually just specialise in a certain area, which is actually really good. You get these smaller companies who actually specialise in that, who are our IRATA members, and yeah, they do exist. The technician search, we've got that in place as well. So first and foremost, each technician has got a certification to back up what they've done, the qualification. They also carry these, not just a logbook for logging the hours in, but they've got these like Cscs cards, like the photographic ID cards, which they've got the hologram in the back, just to verify who they are. And background checks can be run further through the IRATA website. So and I've seen this with like big principal contractors, they're actually hiring in a small rope team to do the work, who have come in individually, been picked individually to do the work. This is a way of doing a background check on the actual technicians. So there might be a company, for example, who I've seen this with entertainment companies actually, they don't want to employ a member company or a load of rope techs to go on site. They just want a small team just to come there, just in case any snagging works or rope access work needs to be carried out. So this is one, mechanism they can use to actually do the background searches on them. You put the name, you put the IRATA number in, and it tells you whether that technician's valid. It gives you the expiry date of the certification, or it'll say if it's actually void and invalid. Other little checks as well. It's quite rare this happens, but you do get some small operations who claim to be IRATA member companies doing it to the IRATA standard. So you can just check over the logos. As I say, if you are, probably can't see the slide actually because of the, I'm not sure if you can see it there in the corner, but on the bottom of the logo, you will see a member company number as well to do the background checks. So key issues, one of IRATA's roles, the double protection. So that's a constant thing we're actually drumming out there, set in stone. To be fair, it's actually, I've never come across it myself, actually, anybody working on single points of attachment, thankfully. But that is one thing that's constantly forced out there. We're force feeding it to all the member companies. Anybody involved in rope access really is this double protection, independent protection. So you might have two attachments, but if it comes back to one point, that's not good enough. We're talking about two independent attachments all the time. Anchor strength. Again, the requirements for that is something we're pressing home all the time. Got to be unquestionably reliable. We've got to withstand this 15 kilonewtons of force that's applied to them as a minimum. So 15 kilonewtons equates to roughly 1.5 tons, metric tons of weight that'll be required to move it. That's a lot of force that it should take. But that's the minimum what we work to. And say it's the safety margins that's what we deemed safe to work with. We wouldn't go ahead if we can't quantify that anchor to be that strong. So we're using structural anchor, structural members of buildings or oil rigs or whatever for the majority of the time. But we can also use tested anchor points, which will be chemical fix or mechanical style expanding anchor points, and these will actually be tested and certificated before we use them. Or we can even add PP onto a structure as well, which is all certificated. The knots, it goes without saying, they've got to be fit for purpose. And we don't actually go in showing off our huge array of knots that we've learned over the years in climbing. We use a select amount of knots, which is documented in the ICOP, which is quite important to take on board, because and all technicians are aware of the knot strengths, the limitations, when we shouldn't use them. We only use a small selection of knots, maybe 5 overall. I would say 3, to be quite honest, are the most common ones, 3 different types. But without going into them, all technicians need to be aware of that. Obviously, level 2s and level 3s have got to be fully versed with recognising them, tying them, making sure they're dressed correctly at all times. In effect, knots are the weakest link in the chain. So I've talked about all like the anchor strengths there being 15 kilonewtons. We've got these double points of attachments. The ropes themselves, a terminated rope, sewn terminated rope, is 11 millimeters. It's a nylon construction, super, super strong. It'll probably take in excess of 3,000 kilograms before they break. I've actually seen it firsthand. We've destroyed a lot of these in test centres. They're strong, but as soon as you introduce knots into them, they actually weaken the strap, they take them down. IRATA's interpretation is that as soon as we introduce knots in the rope, and we have to, because we've got to terminate these ropes onto anchor points, then we just assume that the rope strength has actually been halved overall. So as I say, it's the weakest link in the chain. But even without taking that into account, you've halved the strength of the rope, and then what we usually do is take a fifth of that as to ascertain a safe working load. The protection of the ropes, so it goes without saying, really. I'd say it should be fairly common knowledge, really. These are our lifeline, really. So it's highly important we protect them. Now, it's something I did bring up right from the outset. Just because we've got 2 ropes, we don't go into a job thinking, oh, well, it doesn't matter if the rope snaps, we've got another one. We don't want that in the first place. So these are very, very carefully managed, and it's something IRATA, through webinars and videos and even poster campaigns, but we're spread out into the workplace. I think what's happened, you know, when I started rope access, were a lot of climbs and cavers, and this is ingrained in us: look after the rope, because that's your lifeline. But what's happened over the years, we're getting tradespeople coming in, which is great, but they've perhaps not got that same appreciation of their rope access equipment as maybe we have. So it's something we're constantly working to try and educate them to make sure that they stay on top of this. And if I bring it to the next slide here, we've got this hierarchical approach to the protection of the ropes. So the ropes are really strong. They are nylon construction, kern mantle construction. So you've got this core of inner strength there with a sheath protecting them on the outside. They are super strong, but as soon as you put them against a hot surface or an abrasive edge or a sharp edge for that matter, it's just going to be like a hot knife through butter. It'll go straight through, especially with weight applied to that rope as well. So this is why it's critical importance we protect them. So with the hierarchical approach, what we do is very careful hazard identification on the site. You know, we'll do a site visit prior to any work commencing, looking at all potential, you know, what the rope might come into contact with. We're going to remove that hazard if possible. If we can't do that, we're going to be rigging to avoid any contact. And if we can't do that, the last port of call, we've got to put these rope protection in place. Now, in a lot of cases, if you're on top of a bridge, building or something like that, you've got nothing above you where you can rig to take that rope further away. So you actually are running the rope, say, over a parapet edge. We've got a lot of stuff now on the market, you know, Kevlar, special edge rollers that we can put into place. So there's no excuse to use something makeshift. We shouldn't be doing that. That shouldn't be happening. That's something we've got in place at the moment. We've got some really good rope protection. As an industry, we've probably got some of the best kit we've ever had now. It's out there in the marketplace. Dropped objects, again, coming from a climbing background, as a lot of my colleagues will actually back me up on this. But, you know, if we drop something out in the mountains, it's actually, it could be a life saving piece of equipment we're dropping. So we're, you know, we treat it with very, very carefully about keeping stuff attached all the time. And we're trying to educate the general masses, they say, we're doing rope access or any work at height for that matter. And again, we've got this poster campaign going out there. We're educating people. We do constant safety bulletins with this as part of the toolbox talks. These will always, as like the anchor line protections, we'll always be talking about ways or the approach we need to take to actually control this. I tend to find with if we're actually using tools and equipment on the ropes, so we tend to find we've got these engineered controls along with the administrative controls, along with the PPE as well, but it's usually all included on the work sites there for the dropped objects. Also take into account wind carry as well. So obviously if some of these structures wrong, we can, if something is dropped, it could be taken quite a large distance. So again, these things are actually factored in with exclusion zones. That's how far that our planning actually goes ahead with this. And then we'll probably employ sentries at the bottom of that as well. So, you know, even working on a wind turbine in the middle of nowhere, we've still got a duty of care to people, and we've got to be aware that somebody could be walking under a structure. And you can bet your bottom dollar if somebody's hanging off a structure, members of the public will be drawn to that and walk over and go, you know, what are they actually doing? Is that some sort of circus act? So that, you know, we've got to be mindful of that. We can't just write them off. We've got sentries there to make sure that nobody comes near, as I say, these massive exclusion zones. Another thing IRATA gets involved with is this work and safety analysis. So this is where all the information is fed back to He's actually ex-HSE, Dr. Chris Robbins, and he collates all the information. He puts it together, all the hours performed on rope access around the globe from all the member companies, and look at all the statistics from near misses, incidents and accidents as well. So we basically can learn from that, look at the problem areas. We'll see for this next slide here, we've got the accident rates all the way through there. We've collated through from 89 up until last year, and all the areas that are causing the problems. Obviously dropped rope, on rope error there, third party acts or emissions, rope damage is all in there, and that's broken down into the report. IRATA gets heavily involved in behind the actual testing equipment along with the HSC, so they've commissioned a lot of the work and research is carried out here. So this company in question, Line Equipment, who the chairman's actually, he's a director of, it had been commissioned some time back now by the HSC to look further into the testing equipment, look at the parameters, the performance, what they failed at. So they're destroying a lot of equipment in effect. So we can actually see, not a hypothetical how it's going to be formed, but to actually see, in arduous environments, how they perform as well, so we could learn more about it. And that information is also documented and fed back out into the industry. A similar slide here, again, Paul Seddon, who's the author of the ICOP, he was commissioned by the HSC to look more into the suspension syncope, harness-based trauma. It's got different names around the globe, actually. We have learned from other harness-based activities that there are issues hanging in a harness for obviously rescue purposes, or, we've got to manage that. So Paul was commissioned by the HSC to do more research into that. And that information was actually picked up on by the HSC and used as part of their guidance notes in 2009. Thankfully, in industry, certainly rope access, we had no incidents at all whatsoever with the suspension syncope. It does remain largely hypothetical, but it's not to say we're just going to sit back and let it lie. We'll obviously carry on working towards that and trying to resolve that matter and take all measures necessary. And on a final note, LOLA, which is the lifting equipment, lifting operation, lifting equipment regulation, that really quantifies what we're doing. So it's actually, that's in our ICOP. What we're seeing is simply as a load under LOLA, and all our equipment will be treated as such. It'll be treated as lifting equipment, so it'll be inspected under the regime of LOLA every 6 months, as opposed to the 12 months what the PPE regs stipulates. But planned and managed properly, i.e. level 3s on site, used in a safe manner, and as I say, the equipment regime will be adhered to for that 6 monthly for all the equipment we use now. That brings us to an end. So hopefully I've managed to shed a bit more light on it. Thank you for listening, bearing with me on that, as it's a bit of a
we've got a few questions coming up, actually.
Right.
So first of all, absolutely fascinating. I've got sweaty palms here. I've done some mountaineering, but I thought that aviation was the only work that got you to get your head in the clouds. But blimey, that picture of the suspension bridge was something awesome. So fantastic.
Excellent.
Now we've got
I think about this one, Andrew. I can dig it out. I'll double check if it's a Humber bridge or not, because I'm sure that's what we've done.
There were a few questions on that, Galina. So if I start and start going through these, and by the way, anybody that might have a question later on and we can't answer or we run out of time, can you please put your question in an email form to Alan Dunn. So Alan is our chair. So it's Alan Dunn, DUNN, 0914@aol.com. It is in the chat list if you want to look at it before we finish. So Russ, first question, and actually this comes from Alan, our chair. What is the break-in strain of the rope, and when and how often should they be replaced?
Okay, yeah, it's a really good question. Now, the break-in strain, I did mention it briefly. If it's sewn terminated, which means as part of the testing criteria, they'll look at what they actually fail at. We use a nominal diameter of 11 millimeter, and that will take in excess of 3,000 kilograms before it'll fail. Now, I mentioned before, because we're introducing knots in it, we generally divide that figure by 10 to achieve a safe working load. So the safe working load of the rope is still 300 kilograms. So that's 3 times a normal person's body weight. So again, that's the kind of margin we're looking at. The time span of the rope, I've had to get rid of a rope after a day. If it's got contaminated, we simply get rid of it. The manufacturers stipulate 10 years for textile and plastic items generally. That's most manufacturers, that is. However, there is a caveat in that. With moderate use, they might say to reduce that. With heavy use, they might say take it down to a year and get rid of it after a year. But that's obviously a competent person will have to define what kind of regime you've got in put into place. It depends on the environment you're working in. I've worked in crude oil tanks. We've got them contaminated. We've contacted the manufacturer and they've said, you're fine, you're grand for working up for maybe a month, but we recommend you get rid of the ropes after the contract. So we could actually price that into the job. And that goes for all the harness, all the PPE, in fact, even the helmets, because you know the contamination can affect the performance of a helmet as well. So it's all factored in there.
Great, thanks. And I suppose it's a little bit like lifting tackle. Even if it's not contaminated, storage between jobs is also important.
Absolutely.
How you store and where you store.
Yeah.
Okay, thanks. I have one from Gemma Hallifield, part of our committee, and she's got a parenthesis here, only half serious, but her question is, this looks like awesome fun. What do you need to do to become trained for this sort of access?
It is awesome fun, to be fair, and to be quite honest, quite a lot of the females that come into it, they outgun the males. They're actually better on the ropes. They nail the technique quicker because there was a slide used, using the foot loops. It's the lower body strength, and females adopt that a lot quicker, so they tend to be the quicker and more efficient in most cases. You just basically, if you've got to find an IRATA member company, some really good ones in the UK. I arguably two I actually work at. There's one based in Sheffield, there's one in Cumbria, for example, and they're great instructors as well. It's quite a rewarding week just to do for the laugh more than anything. And it is a very physical week, but it's quite a rewarding one as well, especially when you've come out of the assessment at the end. I'm pretty sure Galina's done her qualification as well. So
no, I can confirm, because I've done my level 1. It's really physically demanding, but yeah, it is lots of fun.
So talk to Gemma about that then, Galina. Okay, now another one from our committee member, from James Carter. His question is, so first of all, he says really interesting topic. Well, I concur with that. His question is, what level of competency is required to thoroughly inspect a harness, and what's best practice on inspection?
Brilliant question. Really, really good question. We do, in the IRATA training, we actually do an awareness. We used to say that level 3 was competent. However, we think that's not enough. I'm not saying that they're all non-competent, but within IRATA we do a strong recommendation to do further training. You can actually get PPE specific inspection courses. Now, what we've got to be careful of here, I've seen a lot of companies driving up and down the motorway saying Lola inspector, and they say they can inspect the harness. There's no such thing. Lola's legislation, it's a regulation. PP inspection is a specific thing, so they have to have an understanding of how it works before they can inspect it as well. It's quite an in-depth course as well. I've actually done it. It's a week-long course. And for myself, I am a bit of a dweeb, really, when it comes to, I'm quite geeky when it comes to the climbing equipment. I'm genuinely interested in that. But I would say, to get back to your point, it is quite a thorough course to do, and to make that call as well. You learn about the documentation side of it as well. It's not just inspecting it from what you're actually seeing with it, but the physical, function checking and tactile checking of it. But it's all about the logging of the use of the equipment. We've got to log the hours. There's got to be complete traceability in all the equipment. So if anything gets contaminated, we can take it out of the system quickly. If it gets damaged or quarantined, we chase it out of the system. We have to write reports on that as well. And that goes to the smallest component that's used.
Sounds a bit like parachute checking and the.
It's exactly the same mindset. Yeah, it is.
Okay, so this one's from me. Apologies. It's something you said at the beginning of your talk, I think, Russ. How do you overcome any resistance to rope work from safety specifiers? So the clients, basically, who may be unaware of the background and all that we know and you know about IRATA. So how do you overcome these worries they might have?
Sure, that's a really good point as well. I mean, ultimately, that's what's led me to have the qualification I've got. Was the main thing that I thought, well, rather than fight it and turn into a pit bull and get into a corner and start arguing the task, I'll go down the same qualification route the health and safety practitioners, and so we could create a better synergy with the rope access teams, so we can meet them on their level and vice versa. We can create a better understanding, see where they're coming from, and to allow that two-way communication. It is quite difficult. So, to be quite honest, the majority of health and safety practitioners are warming to it now. It's mentioned in IOSH qualifications. They are becoming more and more familiar with it, but we're still seeing a little bit of, oh, don't use that. It's better to use a drone, or it's better to use another method. The point of my presentation was to say, well, there is that, and we are aware of that, but just to bear us in mind as well, it is a super safe system, highly regulated. I would always point health and safety practitioners back towards the ICOP as well, and point them through that, because I think it's a super document, as I've mentioned.
I think I'd like to add to that the actual event that we're having today, it's another step, to promote rope access and actually ensure the health and safety professionals who are not really aware of rope access. And I know that I've been in this situation myself, like 5 years ago. I would say, never ever, oh my goodness, there are people on the rope. No, spend thousands of pounds on scaffolding and that type of thing. But now, you said, after I started learning it and all that, I'd be more confident with trained rope techs rather some random scaffolding company.
Okay. Now I've got another question. This is also from Alan Dunn. The question is, when setting up the gear, is there a second check by someone else to ensure all is okay?
There's usually a fourth, fifth, and a sixth check.
Okay.
It goes on. It's continual checking. We can't. It's usually, it depends on the type of sites we've been on. If we're onshore, for example, you could get the team involved in setting up, then it'd be overseen by the level 3, and he'd continually monitor those anchors. You can't just leave the equipment and go, right, okay, set up, we can crack on with the job. There's continual monitoring of the equipment. So I'd say it is continual. I wouldn't say we do it, by rule, we do 2 checks, then jump over the wall and off we go. No, we're constantly checking that, because in the back of your mind, if you're part way down, 100 and 200 foot drop or whatever, you're thinking, what's going on up there? Did I leave that carabiner undone? Have I done this? And you don't want that in your mind, so it's constantly checked. But even leave a lot of people by the anchors as well. So if we have got a team overside, we've got a team on top as well monitoring the anchors, which it does install a lot of confidence as well.
All right, thanks. Well, talking about anchors, this is a question I put in at the beginning, so you might have answered part of this, but the question is, how do you usually attach the working and safety lines to the structure you're working off?
It's done through certified anchor points, certified slings. So these can be a wire sling, or it could be, the company called Spanset UK, they actually make a lifting sling which got a breaking strength of 70 kilonewtons. That's actually been CE marked, or say it's been certified for PPE use now, so we can use those. It's all certified slings we go around, and it's whatever's appropriate to the structure as well. So if it's quite an abrasive surface, we generally use something more robust like the wire slings, but it's all quantifiable and it's procured from a proper equipment supplier as well. It's not something third-party sellers will do on eBay or anything like that. It's all.
It looks, Russ, it looks like I wasn't the only one who was sort of pondering about the standards for anchor points. I've got a question here from Patrick O'Connor, who asks, what statutory requirements are required on anchor points for overseas jobs? Do you receive copies of the 6 monthly reports and any remedial works, and how much do you trust such reports? Good one.
Yeah, it is brilliant. Overseas work, they vary. Generally, my experience when I've been overseas working, I've been using structural anchors. So we've had a report from the engineer there, and to be quite honest, the structure when we're going off, you're looking at main I-beam supporting an entire building, so they're not going to be pulled down. So we're looking, we know common knowledge will tell us what it's going to take in excess of 15 kilonewtons. If we're going off installed anchors such as eye-bolts, that's a different matter. We'd really need assurances on if they're quantified. We can actually take test kits out, and I've actually done this on a few jobs in the UK and Europe. We can actually put what's called a proof load or a proof test on the anchor to make sure it withstands a certain load within our legislative requirements before permanent deformation occurs. So that's something we'll do further tests on top of that to make sure that they meet our standards. But it's quite a difficult one if it's been, obviously structures is a no-brainer, that's quite easy to get around that. But if it's something that's been installed by a client, I would like more information on it.
Okay, yep, thanks for that. Another one from Patrick then, and this question is, will each level of rope access technician require regular medical checks and random drug testing?
Yeah, well, first of all, the medical checks will be, it's industry specific. So if you go into wind turbine, for example, they make you do the GWO, the Global Wind Organization medical, same for a PITO for working in oil and gas. The railway has, for any sort of infrastructure on the railway, to have that qualification to work in the railways. It's all industry specific, the medical. For the training itself, there's on the IRATA website, there's recommendations of what kind of fitness level you have to be. You've got to be minimum age, for example, fitness, and they give you a kind of a guideline, making you aware you've got to be fit enough to actually to carry out that. Drugs and alcohol test is mandatory in a lot of industry sectors. Our IRATA will not govern any of that side of things though. All they stipulate is that the level 3 will have to have first aid training, but as far as like the actual medical background of the person, that's up to them really, or the industry they're going to go into.
I can add a bit on the drug and alcohol side of things. That it's generally what's the company policy, what the company policy is. Again, I can bring in an example of our company, because if we're doing lots of work for network rail, and network rail specifies, that there are random drug and alcohol tests doing, and as this is one of our main clients, then we've just incorporated it in the company procedure.
Yeah, so dealt with in that way. Thanks very much, Galina. I've got one from, and I hope I'm pronouncing his name correctly, Marios Sikouris, and the question is, are the loads that you refer to, are they referring to static loads or dynamic?
Well, what I mentioned before, I gave the figures in kilonewtons, so that's a unit of force for all fall protection equipment, or any PPE for that matter. We're looking at a force where it'll fail at. So we've got to look, that takes into account the dynamic loading, yeah.
Thanks. Another one from Patrick O'Connor here. Regarding welfare regulations, what length of time could a technician be on line? Is there a maximum length of time for a technician to be in a confined space? So,
yeah, it's industry specific. It depends on the exposure levels, what kind of environment they're in. That can vary. With the work comfort seat, I did point that slide out. Say if you've got somebody in a really nice, comfortable environment, it's nice and warm, there's no driving rain or external conditions, we usually rotate them around about an hour, but with close communication with that technician to say, are you comfortable? Do you want to stop and get off the road now, or do you want to change over? In some cases, we just rotate the teams. It really depends on the situation, that really. It's I'd say application specific is a word I like to use.
I think in this case also I would like to refer to HSE fatigue calculator. And it's also, once again, so there are quite, there are quite a few clients and there are quite a few requirements, because basically I will probably say that there is not much difference for a rope tech from a person generally on site, you know, because if it's cold, if it's wet, I don't think that there are any extra health hazards introduced to the rope tech, basically for the reason because they have been suspended in the harness. So I said, and it's pretty much it's the same approach as for the rest of site operatives. You know, if it's cold, wet, windy, then you know you need to rotate and you need to provide more breaks.
Okay, thanks very much. Well, I notice now it's come to 8:30, and conveniently that was the last question I've got here in the chat room. Just a reminder to everybody else that please, if you do have some additional questions, please put them in an email to Alan Dunn, and I just pass over to Alan now. Thanks very much.
Thank you, Andy. And a massive thank you to you, Russ. I have to say, it was a really engaging subject matter, and it's clear to see your passion, your enthusiasm for the subject as well. But you really did give us a comprehensive overview. And personally, I just wish I was 30, 40 years younger. but it was great, really engaging. And, you know, there's food for thought there for a lot, for cost saving. And, you know, you articulated it absolutely fantastic. So really, thanks very much again. And thank you, Galina, for getting it all sorted and taking the lead on this. So just a reminder to our other members that's still with us, please look out for any mailers, LinkedIn and Twitter. We have got an event on leadership and CV writing coming up in December. And not forgetting the good news, really pass the word around. Hopefully we've got our first face-to-face as East Midlands branch in March. So watch out for us. Take care and have a good evening. So thank you. And if we can just have the usual 10 minutes for the committee members, and if you'd like to stay over, you're more than welcome, Russ, and obviously Sarah as well. Don't boot Sarah out, please.
Yeah. Thanks, Alan. Just a very quick one, Alan. Great meeting tonight. Thanks, everybody. Just to remind the attendees that you will be receiving a short feedback survey in the morning. And if you can get that back to us, that would be absolutely fantastic. Brilliant meeting. Thanks, Russ. Thanks, Galina, for leading on this one. Absolutely fascinating. Really, really nice. Thanks, everybody. Good evening.
Thank you.
And now the committee guys are staying on for a while, for 10 minutes.
Yeah, we're just going to have a bit of a 10-minute session, Brenton. Thanks. Yeah.